we have our empirical rule. All right, to do normal distribution in the calculator, we do second bars, and it is CDF. All right, so second bars, number 2, normal CDF. This will be very important to you in your stats and prop class when you get there. All right, so our lower limit, we want between 10 and 90. So our lower limit is 10, our upper limit is 90. That funky looking U there represents the mean. So we have a mean of 50. Standard deviation is this funky looking little R thing. So our standard deviation is 20. So the probability is 0.95 and or 95%. All right, for this one, you do second bars, number 2, normal CDF. We want between 5 and 95. The mean was 50, and the standard deviation was 15. So that's about 99.7% or 0.997, which is what we got when we did it on paper. Second bars, number 2, normal CDF. We want between 53 and 81, so our lower limit is 53, the upper limit is 81. Our mean is 67, and our standard deviation is 14. Not 144, just 14. So that would be 0.68 or 68%, 0.683 if you're going to the nearest hundredth. Second bars, number 2, we want between 16 and 58. Our mean is 37, our standard deviation is 7. So that'd be 99.7% or 0.997. Confidence intervals and margin of error. All right, this is the formula. You may see that in your stats and prop class. We may work with that a little bit after the OC, but for the most part, we're going to do stat test A and stat test 8, and that will give us our confidence interval, and if we're looking for the margin of error, it's half of that. So if we know the mean, we'll use stat test 8. If we have the proportion, we'll use stat test A. All right, so stat test 8, you've got to make sure stats is highlighted. It's our mean, our standard deviation. N represents the sample total, and C level is our confidence interval. All right, to find the margin of error, we find the confidence interval, subtract those, and divide by 2. Okay. A study by the Department of Education of a certain state was trying to determine the mean SAT scores of the graduating high school seniors. The study examined the scores of a random sample of 169. The mean score was 477, and the standard deviation was 98. So we're going to do stat test 8. So go to stat, which is here, over to tests, and if we have the mean, we're using number 8, T interval. All right, you want to move the little cursor over here to stats, Press enter. Alright, our mean score in this was 477. The standard deviation was 98. The sample or total of people we sampled was 169, and the confidence interval was 95%, which is 0.95. So that's stat test A when you're given the mean. Calculate that. And this represents your confidence interval. This should be the information you typed in. 477, standard deviation of 98, 169. So the confidence interval rounded to the nearest tenth would be 462.1, 491.9. Alright, we got 79 students in the high school, a mean of $2,100, standard deviation of $1,400, and a 95% confidence interval. So we'll do stat, go over to test. I'm just going to press 8. It's still on stats. So my mean was $2,100. My standard deviation is $1,400. My total population or sample population is 79, and my confidence interval is still 95%. So that gives me $17.86 to the nearest dollar, 2414. And that is my confidence interval. Alright, so random population sample of 950 is drawn from a larger population. The standard deviation is 4.8, the mean is 44.2. So we do stat test 8, type in all that information. And it will give you out your confidence intervals. Alright, if you have a population proportion, which means we do not have the mean, we're going to do stat test A. This we just have the number out of, the total amount, and the confidence level or interval as a decimal. Alright, a survey was given to a random sample of 185 residents. 74 respond with a 95% confidence interval. Alright, so I will go to stat test. You can scroll all the way down to A. I usually just do alpha math or alpha A, but you can scroll all the way down to A and press enter. Just takes a little bit of time. Alright, so I have 74 respondents out of 185 total with a 0.95 confidence level. So my confidence interval is 0.329.471. Alright, 60% of the people. So 60 of 150 gives me 90. I've got a total of 150 in my sample with a 95% confidence level. So stat test A. Now I'd put in 90, 185, and 0.95. Stat or test alpha A, 90, 185, then 0.95. I got a different confidence interval than it's right here. That's not right. 150, not 185. Hey, good. Okay, well, as soon as we get done with this, I will do that, and then we can do it today during 7th. So I'll see you today during 7th. Okay, or tomorrow, whenever. All right. That's what we were going for. All right, so when you have a table, so we have 75 total, 90% confidence interval, and we're looking at the college students who use the payphone. So 12 students use the payphone, so it's 12 out of 75 with a 90% confidence interval. So I do stat test A, 12, 75.90, calculate that, and it will give me my confidence interval. All right, this one is a total of 100. We want who were injured. So that would include you, Isabel, you were injured. Yeah. So that would be 22 out of the 100 with a 99% confidence level. So we do stat test A. And we'd put 22, 100.99, and that gives us that particular confidence interval. All right, margin of error. You find the confidence interval, subtract, and divide by 2. Here is the formula. If you want to go through that, like I said, we'll probably kind of look at that after the EOC. All right, so I have 85 and 17. I don't have the mean, so this would be stat test A. I have a 95.95. Type that in, get my confidence interval. To find the margin of error, I subtract the confidence interval and divide by 2. All right, I still have out of a total, so this would be stat test A. Once I get my confidence interval, I subtract 0.342 minus 0.298 and divide by 2. And that will give me my margin of error. It is half the length of the confidence interval. All right, same thing for means. This formula is super simple. The margin of error for means, just S divided by the square root of N. All right, so this would be stat test 8. You find your confidence interval, subtract, and divide by 2. That will give you your margin of error. So stat test 8, still finding the confidence interval the same way. It's just to find the margin of error, you subtract and divide by 2. All right, so stat test 8 gives us, this is the same problem we did before, so it gives us that confidence interval. Subtract 4801 minus 4199, divide by 2, you get a margin of error of 301. Okay, so that is what we are going to do